lecture 3 of 4, 8.2 asymptotes. Objective. Okay. First, find the vertical and horizontal asymptote. Okay. So for vertical asymptotes, x is equal to a. A line x equals a is a vertical asymptote for the graph of y equals fx if either limit fx as approaches a from right is equal to plus or minus infinity. Okay, or when limit this function x approaches a from left, is equal to positive or negative infinity. How we can write down in coordinate. This is not good actually. So this is the way how to remember. Okay, this is a, x equals a. It is value for y. So a x infinity. So this is for y when a equals infinity. Okay, so x equals a is a vertical asymptote. Okay, so same like this. A infinity, x, y. So when that one you have one infinity sign, one value, you can conclude that x equals a is a vertical asymptote. It is not good. It's the way for you to remember and find asymptote. And how to find asymptote, vertical asymptote? You have to, first step is direct substitute. Direct substitute. When you get negative or positive infinity, it shows that this is vertical asymptote. Or factorize. Okay. If you get that one is infinity over infinity, this one is indeterminate form. You need to polynomial over polynomial. You factorize, cancel, simplify, then get the asymptote. Okay, or multiply by the conjugate. This is in lecture 2, infinite. Okay, limit to infinite. Okay. Therefore, x equals a is a vertical asymptote. Okay, for vertical asymptote, let's say fx is equal to 1 over x. Okay, and x not equal to 0. And here, domain is okay, x not equal to 0. So 0. Domain is real numbers except 0. So from negative infinity to 0, union 0 to infinity. This is domain for fx. Domain for fx. The next step, okay. That vertical asymptote, when the values of x that will make the function undefined. The function undefined when x is equal to 0. So x is equal to 0 is a vertical asymptote. Okay. Is using graph. Okay. When x approaches 0 from right. Yeah. Right. Okay. The graph fx tends to positive infinity. When x approaches 0 from left, the graph approaches tends to negative infinity. So this is negative infinity. Okay, substitute 0, negative. So 1 over 0 is infinity, negative to give the sign negative. Here is 1 over 0 infinity, but for positive, so positive infinity. So when that one is actually changed to coordinate, x 0, y negative infinity. One value, one infinity sign. So we can conclude that x equals 0 is a vertical asymptote. Same like this case. Okay, x equals 0 is a vertical asymptote. So x is equal to 0 is a vertical asymptote. For horizontal asymptote means that where value y is equal to b. The line y equals b is horizontal asymptote for the graph of y equals fx if either a limit fx x tends to negative infinity, and the answer is b, something value, not infinity. When limit this function as x tends to positive infinity, and the value is value, we get the value, not the infinity. So here, this is x value, this is y value. For coordinate, x value is negative infinity, y value is b, same like 2, 3, 4, 5. So this is y value. Y is equal to b is a horizontal asymptote. So here same as this one. Okay, x value and y. So y equals b is a horizontal asymptote. Okay, that is the way how to remember the horizontal asymptote. So this one also check the previous lecture, that is lecture 2, case 1 and case 2. Okay, method divide with the highest power of denominator. Okay. Okay, example horizontal asymptote. Okay, here is domain all real numbers except 0. Okay, so the graph is when x tends to positive infinity. Okay, positive infinity, 1 over infinity is equal to 0. So negative positive infinity 0. This is y is equal to 0. So this one is equal to horizontal asymptote. Okay, and when limit 1 over x as x tends to negative infinity, 1 over negative infinity is equal to 0. So negative infinity 0, y equals 0 is a horizontal asymptote. Actually, asymptote there is a equation y equals 0, not 0. Okay, there is equation line. Okay, line, dotted line actually. Okay, when x approaches tends to negative infinity, so the graph almost touch x-axis but never touch, just almost near to the x-axis. Okay, and y equals 0 is a horizontal asymptote. Same this one also, y equals 0. Okay, so okay, all for all the graph for 1 over x. Okay, this one the first case, vertical asymptote, when x approaches 0 from right and x approaches 0 from left. Okay, this one the graph goes to up, this graph goes to down. Okay, and when x tends to infinity, the graph goes to 0, almost 0. Okay, and when x tends to negative infinity, the graph goes to negative 0. Okay, so join the two, this line. Okay, this is the graph, and this is also the graph. So x is equal to 0 is a vertical asymptote. Vertical, straight up, turns up. Okay, and y equals 0 is a horizontal asymptote. Okay, so as you can see that y equals 0 is equation, x is equal to 0 is equation. Okay, you cannot say that 0 is a horizontal asymptote. This is wrong statement. Okay, so you can give full sentence, y is equal to 0. Okay, line, y equals 0. This one is a horizontal asymptote. Vertical asymptote. Okay. Example 1. Find the vertical and horizontal asymptotes of this function. Okay, x not equal to 0. So domain all real numbers except 0. Okay, domain all real numbers except 0. You can check from the given domain here, domain transfer to interval form. You can check, you can find when x approaches negative infinity, when x approaches 0 from left, okay, when x approaches 0 from right, x tends to positive infinity. Okay, you should check 1, 2, 3, 4. This one maybe produce vertical, and this one and this maybe produce horizontal asymptote. Horizontal asymptote. Okay, try to find this. Okay, limit x approaches 0 from left. Okay, so and 1 over x squared. 1 over 0 squared positive. 1 over 0 infinity positive. And limit x approaches 0 from right. Okay, since x squared give positive 1 over 0, 0 positive, also positive infinity. Then when x this limit for this function 1 over x squared, as x tends to negative infinity, 1 over negative infinity squared also give positive. So 1 over infinity is 0. 0. Okay, and limit 1 over x squared, as x tends to positive infinity, 1 over infinity also 0. Okay, so this one, okay, this one, okay, you can take this one, 0 infinity. So just use the pencil to check. Okay, so this one is just simple. Okay, and this is x equal to 0. X is equal to 0. And this one negative infinity 0, negative infinity 0. Value for y is equal to 0, y is equal to 0. So we can conclude that here, okay, x is equal to 0 is a vertical asymptote, and y is equal to 0 is a horizontal asymptote. You have to write full sentence: vertical asymptote, horizontal asymptote. So you can, okay, erase this. Okay, this is just for you. And for example 1, okay, when x approaches 0 from left and right, okay, the graph tends to up, positive. So limit this one, okay, positive infinity, and also when x approaches 0 from right, positive infinity. For horizontal asymptote, okay, when x tends to positive infinity and x tends to negative infinity, the graph is like this. So join the line and you get the graph. Okay, this graph. Then, okay, graph, and horizontal asymptote is, okay, y is equal to 0. Then vertical asymptote is x is equal to 0. This is vertical asymptote. Horizontal asymptote, okay, y is equal to 0, x is equal to 0. Okay, in full sentence, not 0, not only 0. Must write y, and y equals 0. x equals 0. For example, the next example, determine the asymptotes of this function. Okay, so the first step, try to find domain. Okay, this domain, wherever, okay, 1 over something, denominator, the domain for domain, denominator is not equal to 0. So find x minus, okay, 6 plus x minus 1. So x is equal to negative 6 or x is equal to 1. Okay, now the domain is, okay, do number 9, negative 6, 1, all real numbers except 1. Okay, so you have to get rid of negative 6, 1. Okay, to make sure this function is defined. Okay, for undefined, when x is equal to negative 6 and 1. So here, okay, transfer to the interval union 1 to infinity. So all you have just check. Okay, take here negative, okay, negative here, negative 6 from negative, negative 6 from positive, right, left, negative 1 from left, negative, sorry, 1 negative is left, 1 positive is from right. Then here is x, approaches positive infinity, and this one is negative infinity. So for this one actually for horizontal asymptote. Okay, for horizontal asymptote, if any. Okay, for this case, okay, maybe produce vertical asymptote. Okay, vertical asymptote any, and we just check. We have to check all. So 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2 value for horizontal and 4 values for vertical. Okay. Next step, substitute. Limit this function for her vertical asymptote. Okay. To factorize. Okay. Factorize factor. Okay, x approaches negative 6 from left. Okay, and then substitute. Okay, 6, negative 6 minus 1. Here, negative 6 from left. Also negative 6, right? Itu x. So here answer is actually confirmed 0. Is a negative. 1, 0, then negative 7. Now we're going to check, is it negative on the to the left or to the right? Negative or positive? Check and take one number. Assume this is negative 6 from left. Negative 6 from left. So just write down. This is negative 7, negative 5. So negative 6.01. Okay, take this one. Negative 6.01 plus 6. So this one bigger than this. So 0 is just negative. So negative times negative, positive. 1 over 0. That is positive infinity. Okay, settle for negative 6 left. Okay, find negative 6 from right. 1 over, okay, x plus 6, x minus 1. Substitute value 6, and then here is negative 6 from right. and negative 6. No need to write positive. Why? Because other is negative 7. Okay, and then it's equal to 1 over 0, negative 7. Now take one number here, negative 6 from right here. Negative 6 from right, negative 5, 999. So here is actually negative 5, 999 less than 6. So this 0 just positive. So 1 over 0 negative. So negative infinity. Okay. Let's say for x, okay, is equal to 1. Limit x approaches 1 from left. Okay, 1 over x plus 6, x minus 1. Good. Okay, 1 plus 6. So this one is 1 plus 6, 1 minus 1. So this one is plus negative to the left. Okay, so just take one number to the left here. Okay, and here is 0, 2. So this number, okay, is 0.99. Okay, 0.99 less than 1. So 1 over 7 negative 0, just negative 1 because of 0.99 less than 1, less than 1 minus 1, 0. 1 minus 1 is 0, confirm 0, but just negative. So 1 over 0 just negative is equal to negative infinity. So for limit x approaches 1 from right, x plus 6, x minus 1, and then substitute. Okay, 1, okay, plus 6, 1, just positive, right. So now, let's say here, 1, okay, from right, there is 1.01, okay, 1.01. So, here is 1 over 7, 1 minus 1, confirm 0. But this one 1 plus means that imagine 1.01 more than 1. So just positive. Okay, so 1 over 0 positive or positive infinity. Okay, so this vertical asymptote. Okay, I try to this to find horizontal asymptote. Okay, so for horizontal asymptote. Horizontal asymptote. So limit x approaches negative infinity, and then just take this one. I need to factorize. Substitute 1 over, okay, concentrate this one. Okay, infinity positive. 1 over positive infinity means that infinity is equal to 0. Just write 0. So don't have to write. Okay. So limit x approaches positive infinity. This one x squared. Okay. Also 0. 1 over big number or smallest number is equal to 0. Here, if you want to check, negative infinity 0. Positive infinity 0. This is y value. Y value. Therefore, y is equal to 0 is a horizontal asymptote. Okay, settle for horizontal asymptote. For vertical, here is negative 6 infinity or negative 6 negative infinity. X equals negative 6. X equals negative 6. So, x equals negative 6, and check for this one 1 negative infinity. x equals 1. So 1 positive infinity. So x equals 1. X equals 1. Okay, so x equals negative 6. X equals 1 are vertical asymptote. Okay, settle for this example. Horizontal asymptote y equals 0, vertical asymptote x equals negative 6 and x equals 1. So this graph just for you. Okay, so just you can imagine the graph. Okay, this is the graph. This one is x1 vertical asymptote. Okay, and this one is vertical asymptote. Okay, this is horizontal asymptote. Okay, the line is like this. Okay, then okay, example 3, determine the asymptotes of fx x minus 1 over x squared minus 1. Okay, first thing, check the domain of f. Everything denominator not equal to 0 to make sure f is defined. So x minus 1, x plus 1 not equal to 0, or x not equal to negative 1, or x not equal to 1. Then the domain is number line negative 1, 1. All real numbers except negative 1 and 1. Okay, so okay, negative infinity 1 union at 1 union 1 to infinity. So this one is negative infinity. Maybe this one is horizontal asymptote, maybe horizontal asymptote. And this one, negative 1 from left here, negative 1 from right here. Okay, 1 from left here, 1 from right here. Okay, maybe this one. Okay, vertical asymptote, maybe vertical asymptote. Okay, if any, we have to check. Okay, so try to check. Substitute, find the limit x approaches negative 1 from left, and x minus 1 over x squared minus 1. Limit x approaches negative 1 from left, x minus 1, x minus 1, x plus 1. And then this one can be cancelled. So you have only x approaches 1 over x plus 1. Substitute. Okay, substitute negative 1. Okay, from left. Okay, so let's see here. This negative 2, 0. Let's say here is negative 1.01. And negative 1.01 is more than 1. So the answer is 1 over 0 just negative. That's why that one is negative infinity. Okay, and then for positive, limit x approaches 1 from right. I take this function because of don't have to do twice. Okay, and then substitute. Okay, negative 1 from right, negative 1, 0. Before negative 1, that one is negative 0.999. So negative 0.99 is less than 1. Okay, less than 1. Negative 1 plus 1 is 0, less than 1 just positive. So positive infinity. Settle. For x is equal to 1, limit x approaches 1 from left, then x plus 1. Okay, and x plus 1. Okay, get 1. 1 plus 1 is equal to 1 over 2. Okay, 1 over 2. Or substitute here. Okay, show you. Substitute here. X minus 1 over x squared minus 1. Substitute and you get 1 minus 1. Substitute 1 minus 1 over 1 minus 1. That one is 0 over 0 in determinate form. So you need to factorize. Limit x approaches 1 from left. Factorize. Okay. X minus 1. X plus 1. Okay, cancel. And get limit x approaches 1 from left. 1 over x plus 1. Substitute 1 over 1 plus 1 is equal to 1 over 2. Not equal to infinity. Okay. Then here limit x approaches 1 from right. Take this one. 1 over x plus 1. 1 over 1 plus 1 is equal to 1 over 2. Okay. And here, okay, x equals negative 1, y negative infinity. So this is x. X equals negative 1. Okay. Here also, x equals negative 1, y positive infinity. This one is x equals negative 1. You can conclude that x equals negative 1 is a vertical asymptote. Okay. X equals negative 1 is a vertical asymptote. And take this one. 1. And y is 1 over 2. This is the point, not asymptote. Also 1 and y 1 over 2. This is not vertical asymptote. Okay, only x equals negative 1 is a vertical asymptote. Try to find when x tends to negative or positive infinity. Okay, here and here. Limit x approaches negative infinity or positive infinity. X minus 1, x squared minus 1. Substitute value infinity over infinity in determinate form. Okay, you have to divide with the highest power of the denominator. Okay, x squared. So limit x approaches negative infinity. X over x squared 1 over x. 1 over x squared 1 over x squared over x squared over x squared 1 minus 1 over x squared. Then substitute 0 minus 0 and over 1 minus 0. So 0 minus 0 over 1 minus 0 is equal to 0 over 1. Same like this when x tends to positive infinity. We'll do here, okay? Limit x tends to positive infinity in determinate form and divide with the highest power of denominator 1 over x minus 1 over x squared 1 minus 1 over x squared. Substitute also get 0 minus 0 1 minus 0. That one is equal to 0. So here is x negative infinity, y 0. Y equals 0 is a horizontal asymptote. So we can conclude that y equals 0 is a horizontal asymptote. Okay, for horizontal asymptote, that is y equals 0. For vertical asymptote, x equals negative 1. Or you can do like this, okay? Okay, factorize after substitute in the limit. Okay, when that one in the function, you cannot cancel. The function seem like 1 over x plus 1. No, cannot. Okay, after you substitute here using limit, okay, you can factorize and cancel to change the 1 over x plus 1. Why? Because of limit, we just take the behavior of the neighborhood, not the point itself. So you can simplify to 1 over x plus. Okay, all. Okay, and here also. Okay, either you divide with the highest power or simplify and get just 1 over x plus 1, and it's easier for you to manage and find the answer. Okay, graph. So the graph. Okay, when x is equal to 1, this is just empty circle, not included, but not formed to asymptote. Okay, the asymptote only for vertical asymptote only 1. X equals negative 1. For vertical, for horizontal asymptote also 1. Y equals 0. Okay. Example 4. Determine the asymptotes of f of x equals 2 over square root of x squared minus 4. So first thing, find the domain of f. Okay, domain, denominator. Domain f, denominator, square root of x squared minus 4 more than 0. Not include 0. Why? Because of this one is denominator. Okay, then next, okay, factorize. This one is x squared minus 4 more than 0. X plus 2, x plus 2 more than 0. Quadratic, smiling graph. This one is negative 2, 2. This region. So domain is from negative infinity to negative 2, open bracket, go to infinity. Okay, this is domain. Okay, the next step, okay, you need to find, okay, try to change, okay, here, negative 2 from left, 2 from right. Okay, this one is for vertical asymptote. Negative infinity, to find, to check whether horizontal asymptote is or not. Okay, and then try to find limit. Okay, x approaches negative 2 from left. Okay, if you change this domain to number line, okay, negative infinity to negative 2, go to infinity. So the return is, okay, from here, negative infinity to negative 2, go to infinity. So negative 2 from left only, 2 from right. Okay, no number domain from negative 2 to 2, no x value. So don't have to find negative 2 from right and 2 from left. Okay, so function is 2 over, okay, factorize x plus 2 and then substitute. Okay, substitute negative 2 over square root of negative 2 minus 2, negative 2 left plus 2, okay, So this one is equal to 0. 2 over 0 is equal to infinity. Confirm this one is positive. Why positive? Because of under square root. Okay. The next step, find limit. Okay, as x approaches 2 from right. Okay, 2 over factorize. Then substitute. 2 square root of 2 minus 2, 0. 2 plus 2. So is from right. Okay, we get 2 over 0, confirm positive, then positive infinity. Okay, then next step, find the limit as x tends to negative infinity. So 2 over x squared minus 4. And then when to substitute here, actually we get 2 over infinity. 2 over infinity is equal to 0. Okay, infinity squared minus 4, stay infinity positive, square root infinity, get positive, big number. 2 over big number is equal to 0. Okay, limit x tends to positive infinity. Okay, same reason, also get 2 over infinity, 0. Okay, then so here negative 2 for x plus infinity. So x is equal to negative 2 is a vertical asymptote. When positive infinity, one value for x is equal to 2. So x equals to also vertical asymptote. Vertical asymptote. Vertical asymptote. Here is positive and negative infinity 0, and here is positive infinity 0. This one refer to y. Y equals 0. Y is equal to 0. Therefore, this is horizontal asymptote. Okay, therefore, vertical asymptote. Okay, we have two vertical asymptote. X is equal to negative 2 and x is equal to horizontal asymptote. Y is equal to 0. Okay, that's all for example 4. Okay, find domain. Then see what happen when, let's say, you substitute negative 2 from right and 2 from left. Suppose you get undefined. Okay, why undefined? Let's say we substitute negative 2, sorry, 2 from left, 2 from left, 2 from left. Okay, so this one less than 2, 1.99 minus 2. Confirm this one is negative answer. This one positive. So negative times positive, negative. Set negative is undefined. Okay. So this is graph. Okay, you have two vertical asymptotes. Okay, the graph. Then means that no graph between negative 2 and 2. Why? Because of no domain. Okay. Can find this one using this, or just substitute x squared minus 4y because of here we get positive 2 over positive infinity 0. Example 5. Determine the asymptotes of fx equals ln x. First thing, find domain ln x. Domain f, x, here x should be positive. Number 9. Okay, from 0 to infinity, or change to interval 0 to infinity. Now you need to find limit. Limit 0 from right, and this one maybe refer to vertical asymptote. Okay, infinity refer to horizontal asymptote. Try to find and show, check whether this one x equals 0 refer to vertical asymptote or not. Okay, so limit ln x as x approaches 0 from right. Okay, then substitute ln 0 plus is equal to negative infinity. Okay, then substitute ln x tends to positive infinity. Okay, ln infinity is equal to positive infinity. So here, this one is 0, 0 for x, for y negative infinity. So x is equal to 0 is a vertical asymptote. And here plus infinity, positive, positive infinity. So no value. Okay, means that no horizontal asymptote. Okay, so therefore a vertical asymptote is x is equal to 0. So this is the graph. Okay, asymptote. This one asymptote when x is equal to 0. And when x tends to positive infinity, the graph also tends to positive infinity. Example 6. Determine the asymptotes of fx equals e to the power of negative x exponent. Okay, domain for exponent always real numbers from negative infinity to infinity. So transfer to number line, negative infinity to infinity. So no number here means that no, from here, from the domain, no vertical asymptote. Okay, now you need to find limit x tends to negative infinity, e power negative x, substitute, and limit x tends to positive infinity, e power negative x is equal to something. Okay, here is e power negative positive infinity. So answer is positive infinity. So for this one, substitute positive infinity, e to the power negative infinity equal to 1 over e power infinity is equal to 0. So don't have to write down this one. Okay, so when x is equal to positive infinity, y 0. This is y is equal to 0 is horizontal asymptote. When x equals negative infinity, y positive infinity, no horizontal asymptote. Therefore, y is equal to 0 is a horizontal asymptote and no vertical asymptote. Okay. Conclusion, vertical asymptote when x approaches a, limit is infinite. Okay, So to find that one, just direct substitute, simplify, factorize, or multiply by the conjugate. Okay, check lecture 2. Okay, here limit x approaches a and given poly over poly and check the positive something value over 0. If 0 positive, okay, this one is tends to positive infinity. When this one is negative, tends to negative over negative equals positive infinity. And then positive over negative, okay, is equal to negative infinity. And then negative over positive is equal to negative infinity. Okay, then for horizontal asymptote, y equals b, limit at infinite. Okay, so method divide with the highest power of denominator. Still in lecture 2. Okay. Case 1, when limit fx over gx, x approaches infinity. Okay, poly over poly. Okay, divide each term by x with the highest power of denominator. Okay, case 2, when poly over surd or surd over poly, poly over surd or surd over poly. Okay, either fx or gx by surd function. For poly function, divide each term by modulus x. For surd function, if x is, this one is x, x. Okay, if x tends to positive infinity, divide with positive surd x squared. If x tends to negative infinity, divide with negative surd x.